issues. So, yeah. So welcome all of you for the, actually it is day 3, but technically it is day 2, right? So I would prefer to call day 2. So day 2 of our certified root cause analyst training program.
जस्ट टॉक टू हर बिग टीम है थोड़ा पे अच्छी तरह बनाने के एक बार रिव्यू करने के नहीं तो गंदा दिन हो जाएगा.
Oh, Chandrasekhar, a lot of noise coming. Okay, so let me, yeah. So before I continue with the AD, so let us recap certain important points. Problem means an undesirable gap, so that you can, connect easily with the flow. A problem is nothing but an undesirable gap with respect to quality, productivity, delivery, safety, even cost. You can remember this SQDCP, where S stands for safety, Q stands for quality, D stands for delivery, C stands for cost, and P stands for productivity. Sometimes we also use it to refer to people. Okay. And so in order to, but another important thing we must equip ourselves is our ability to correctly quantify the problem. Our ability to quantify the problem. Because the measurability is very important. Problem, if you can measure it, you can certainly monitor it. Isn't it? If you can't measure, how can you monitor? But if you can monitor it, you can certainly control it. If you can control it, you can also improve it. Isn't it? So if the, if the linkage is disconnected, then it will be difficult for us to improve. If you could improve, and that is what we call it as, a solution, right? A problem is solved. So measurability is very important. So how can we quantify the problem? This question is very, very important. You need to know certain metrics by which you should be able to express your SQDCP. Your SQDCP. These metrics can be called as, even KPIs, key performance indicator, right? So quality related metric, your productivity related metric, safety related metric, cost related metric, and then delivery related metric. Okay, no issues, Venkatesh. Yeah. So can you tell me one metric that can help us to understand quality? Come on, please. And try something whenever, I give you an opportunity. And don't be worried about, giving a wrong answer or giving, the correct answer. Just, answer is very important. That's it.
Customer feedback.
Oh, customer feedback to
Yield.
understand the quality.
Yield.
Yield. Yeah.
First time course. First time
Come.
pass.
First time?
First time pass.
Oh, first time pass. I really appreciate, all the answers. The first answer is customer feedback. How was the quality? You ask your customer. For example, how good was the training? We need to depend on the customer feedback. It works, really works. Why? I cannot directly measure the quality. I cannot directly measure the quality. I can integrate an AI tool. An AI tool can give me a rating of the training, the session, every 1 hour. Possible. That is a direct method. But direct method is not possible. We have not integrated. So I am going for an indirect method. But your indirect method should be a real representative of what you are trying to measure. Very important. Yes or no? Otherwise, we might have a metric and we might improve on the metric, but problem will tend to continue. So that should not be the case. But in using indirect metric is not wrong. It's really, appreciable. But then make sure your indirect metric is a real representative of the, your problem. right? Or whatever the quality, if you say, it should be a real representative of quality. And the first pass yield, first time yield, that is, it's a direct measure of your quality. I really appreciate that answer, because you are not just going for the yield, you are going for the first pass yield. First pass yield, see, yield can refer to quality, but the first pass yield can refer to built-in quality. So what is the difference? What is the difference? I want all of you to be very active, right? So if you have a problem with the camera, no issues, but you can speak, right? Your speaker should not be a problem, right?
Can you repeat the
Quality
question?
and then quality,
repeat the
difference between quality and built-in quality.
When it comes to built-in quality side, it is known, but it's nothing but the SOP standard operating procedure prepared within the organization. I can call as a QA, quality assurance, built-in quality.
Okay, good try, a close answer.
So first
Somebody
time
say-
right and every time right, and first time right and every time right, built-in
Okay.
quality, and
Okay.
you also
Yeah.
save on your costs.
Okay. So imagine your child wrote an exam, right? And got a poor mark. Let's say your child got some 65 marks. 65 is a pass mark only, but still it is poor. So your child attempted and let's say, an improvement. And after the improvement exam, your child got 95 now. Now there are two scores you have now. One is 95, the other one is 65. Now, based on the preparation, how much your child scored? That's the normal preparation, isn't it? The first exam score. 65. That is the actual built-in quality. But the 95 is a boosted score, yes or no? The 95 is a boosted score. Same manner, your yield is a boosted value. How did you boost? All the products that has some problem, some defects, what we do? We correct it, yes or no? We do a correction. We call it, what is the name we use? We call it rework. Yes or no?
Yes.
But what our process produced? Our process produced, parts with certain parts with the defects, certain parts without defects, isn't it? So only that 65% is the outcome delivered by our process. We only boosted that 65 to 95. So first pass yield is a better measure of quality because it takes us closer to built-in quality, not a boosted quality. Are you with me, all of you, on this point?
Sir.
And built-in
Yes,
quality,
sir.
let's understand, the deeper meaning of built-in quality. And by design, we plan to deliver a certain level of quality to the customer. By design, by the design of our product or service, we try to deliver a certain level of quality to the product customer. But what can happen? This quality sometimes can get deteriorated because of failure of your process. Am I right?
Yes, sir.
Like we designed the course with an intention of delivering a higher level of quality to all of you. But the first day itself, we experienced a lot of problem. We are not able to even to conduct the program. So your process can fail and pull down your built-in quality, isn't it? So built-in quality means the quality that is incorporated at the design stage. Now we really need processes which can deliver that built-in quality without any deterioration, the same level. And that's why we are interested in the first pass yield or the first time quality. And first time quality is the nature of the process. That's the nature of your process. And then by nature, it produces certain rejection. And then we try to correct those mistakes and we try to boost our quality. So if you ask me, first pass yield can be a better measure of your quality level than measuring the traditional yield. Hope all of you agree with me. If you are working with certain metric, and make sure the metric takes you closer to the reality. Okay. And I want to measure delivery. Tell me, which metric can help me to measure my performance with respect to delivery?
Number of product
Number
delivered
of
versus
product produced.
Time bound.
time.
Delivery. Delivery means items delivered to the customer.
Production sir.
And
Commitment and time.
Time, sir.
delivery need to be
Time bound, sir.
on time. Very good.
On time.
On time delivery. You ordered food with Swiggy or Zomato, several hundred times.
On time delivery.
Is that all the time you got the food on time?
Not at all, sir. Sometimes.
Sometimes delayed or sometimes on time?
Sometimes delayed.
Okay, sometimes delayed. That
Delayed,
means,
yeah.
the on-time delivery is above 90%.
Yeah.
And the delayed delivery is less than 10%. That is the conclusion. So on-time delivery is measured in terms of percentage. See, so far we are talking only in terms of percentage. Quality, first pass quality percentage, on-time delivery percentage. That means we really don't use any measuring instrument so far. Am I right? We are not able to use any measuring instrument. We are only, recording the event. We are only counting how many times on time happened, whether on time happened or not, yes or no, good or bad. That's the weakest way of measuring or weakest form of measuring. We only have the percentage. We will not have any measured value using any instrument. We are not using any instrument. And out of the two approach, which is good, try to use a measuring instrument. You can be more accurate, yes or no?
Yes, sir.
Because good or bad, it only tells you good or bad, whether you are inside the spec or outside the spec. That's the information coming. How much you are inside, how much you are outside, you will not be able to answer. So the intent, what do you say? The deviation from the target cannot be visualized if you do not use measuring instrument. That is the reason why we try to use a measuring instrument for important characteristics, critical characteristics. We are not just interested in checking it's good or bad. Go gauge and no go gauge and cannot be used everywhere. Wherever superior levels of quality is required, you must necessarily have a measuring instrument. Hope you are getting this point. Okay. So for readings obtained without measuring instrument, finally we end up generating a metric in percentage. We end up generating a metric in percentage. This is known as proportion. 90% is a proportion. 90% of the time, deliveries are happening on time. But 10% of the time, deliveries are getting delayed. But if we ask you how much delayed, you need a measuring instrument. Correct? If we ask you how quickly, within how much time you are delivering, then also you need a measuring instrument. A stopwatch, a clock, that's simple. Because it's a time. Okay. But if you are able to capture the time with the measuring instrument, you can answer both questions. What is your percentage on-time delivery? You can tell. And how far you are close, how far, how much you are away from the target, that also you can tell. Or how close you are to the target, that also you can tell. So every question can be answered. So such measured characteristics or data obtained through measurement using a measuring instrument are known as continuous data. There are two types of data available. One is we collect data using measuring instrument, which is known as continuous data. Whereas the another data, which finally resulted in percentage like yield, percentage on-time delivery, attrition rate, percentage of your employees leaving. There's so many metrics. All these percentage are discrete data. Earlier I told you direct measurement is good than indirect measurement. Now after measurement, whether the measurement is obtained using an instrument or just observation. Out of the two, which is good? The one generated using a measuring instrument. And you can ask me why it is good, isn't it? It can give more information. You can use such data for all mathematical operation. Because ultimately we need data only for some calculation, isn't it? What calculation we do? Addition, subtraction, multiplication, division, so many things, transformation, so many things we do. All of those things will be accurate. Can be more accurate than the data generated without an instrument. All right. And with the instrument also, error can come. All of you are aware of it. Even if you have a measuring instrument, you have an instrument, then also error can come. If the data accumulates error, then your understanding, will go down. Your understanding about the problem will go down. Correct. It's like, what do you call? Your windshield contaminated with so much dust. If all your windshield is fully contaminated with the dust, how can you see the road? Same manner, if the data collected is accumulated with the error, then you can't understand the problem. You might miss out on certain things. So it's very important that we have measuring instrument which can give us bias-free data. Which can give us what? Bias-free data. What is bias? Bias is an error. Now, please tell me one method by which we can correct the instrument and make it work in a bias-free manner. Imagine you have an instrument that has bias. You have a wristwatch. That wristwatch has got a bias. Bias means it either gives faster time or gives a slower time. It never gives the correct time. Now, what should you do?
Calibration.
This is known as calibration.
Need
This is
calibration
known
with
as
the respect to
calibration.
master.
Calibration with the master. So
master.
calibration is important. Calibration procedure must be followed if you use any measuring instrument. Otherwise, you may run the risk of error accumulating your data.
Hello, sir.
Yes.
What is calibration, sir?
Yeah, calibration, correct.
What is calibration, sir?
Which, what are you asking?
What is calibration, sir?
Yeah, calibration. It is calibration. Calibration means, they just check whether everything is in order in your instrument. Right? They might do a kind of overhaul, some kind of servicing. All that they do, the worn out parts will be replaced. All of them are part of your calibration. And then they check the instrument with the masterpiece. Right? With the masterpiece, they will check whether it is giving correct readings or not. If it is not giving correct readings, they'll make the finer adjustments so that it will start giving you accurate readings for every reference within the range of operation of the instrument. Let's say it's an voltmeter, 100 volts to 200 volts. They'll supply 100 volt and check how much reading the instrument is showing. It is supposed to show 100. If it is not showing, they will try to make the adjustment. At one particular adjustment, it will give exact 100. That means calibration is fine. Now 120. Now the instrument will show 120. Then 140, 160, 180, 200. Every place across the range of investigation, it gives accurate reading. That means the calibration is perfect now. Do you understand? So this calibration, along with the calibration readings and calibration certificate, everything will be provided to you. That means you are now sure you got a good instrument. Now the next thing you need to take care is calibration frequency. Calibration frequency. What is calibration frequency? When is the next calibration due? You must know.
Calibration due.
It depends on the usage pattern.
Yeah.
If you use the instrument very frequently, what will happen? It can it can slowly deteriorate, and then slowly the bias will again increase, isn't it?
Yes,
And so, but through experience only you can figure out. And then once in a year, once in 6 months, or once in 3 months, depending on the usage. Because in my company, vernier caliper we never use. We just purchased and then it is lying always, inside the room. And such thing, instrument might work perfectly for a longer time. But very frequently, if you are using, then there is a chance that within 3 months, it might need a calibration. So you need to understand and then judge correctly and decide on the calibration frequency and the usage procedure of the instrument, storage procedure of the instrument. All that has to be taken care so that the readings can be accurate. If the readings are accurate and it is coming from a measuring instrument, you are measuring, the problem the perfect way. You are measuring the problem the perfect way. And so the current state of the metric you want to improve is clearly understood. The current state of the metric is clearly understood. We call this as baseline. We call this as baseline. And the target is also there. Target is also there. Baseline is also there. And the gap is understood correctly. This is the this information is needed for us to initiate the analysis. Are you with me, all of you?
Yes, sir. Yeah. Yes, sir.
Yeah. In a bank, lot of customers complain about the delay in processing their application. Now, one side is customer complaint. Number of customer complaints I can take. That can be a metric. Is it a direct metric of the problem?
Discrete.
Discrete. And it's an indirect metric. So many customer complain, but the exact problem is the delay. Delay in processing of the application. Is there a direct way you can measure the delay? What is the metric I can use to measure, to understand the delay? Low application processing time. So, application processing time. For every application my bank is receiving, I must find out the processing time and keep a record of it. Yes or no? And our processing time is measurable. A normal clock will do. When just only thing is some documentation is required. The moment the customer submit an application, it must be recorded somewhere. And then you process it and come out with a decision and communicate the decision. Your application is received and we are happy to confirm that bank will be offering you a loan of so many lakhs. And then the dispersal will happen. But the application is processed. Are you with me, all of you? In this case, there are two sources available. One is number of customer complaints. Another one is the loan processing time. The number of customer complaints is discrete data, but the loan processing time is continuous data. We already know continuous data is better. We already know continuous data is better because it can not only tell you whether the decision is arrived within the committed time, that also it can answer. So, or how much time the bank requires to process a loan application. That also our data can answer. Yes or no? After processing several thousand application, if somebody asks you, tell me how much time your bank is taking to process an application, you will immediately tell, sir, on an average, we take only, just 48 hours and and arrive a decision. Another bank is telling, sir, we take decision in 6 hours. Hope you understand. And now the second metric, the loan processing time, that gives a more real picture. Yes or no? Very realistic picture. Am I correct? Well, so you have two scenarios, two kinds of data. All your statistical analysis can be more accurate with the continuous data. All your statistical analysis can be more accurate with your continuous data. And only when you have continuous data, the metrics like CP and CPK are possible. The metrics like CP and CPK. Who will use CP and CPK? Manufacturing industries, predominantly manufacturing industries. What is CP and CPK? Process, capability,
And
indices.
capability index.
Process capability
index. Yeah.
Indices, commonly indices. Process, because we have two, CP, another one is CPK.
CPK.
When you say index, it refers to CPK only.
Yes.
Okay. But now the objective is not to teach you process capability index, but to tell you, you need the right metrics to measure your KPI. If it is CP, CPK can be a metric reflecting quality, yes or no? CP, CPK can be a metric that can talk about your quality.
Yes. Process.
If CP, CPK is very high, defects will happen very, very rarely. Right? And if CP, CPK are very healthier, you not only produce acceptable parts, you produce best-in-class parts. Do you understand?
Yes, sir.
If CP, CPK are very high, it not only gives you a higher yield, it also confirms that you are producing high-quality products. High-quality product means parts produced around the targeted value, the customer target. Are you following me, all of you? You are understanding my statements, right? So what I am trying to say is, in your industry, you must be familiar about certain KPIs which can reflect quality, delivery, safety, cost, productivity and things like that. If you are a safety officer, number of incidents, number of near miss incidents on a monthly basis, or number of incidents for every 1 million parts produced. These are all the ways you can measure the safety, your performance with respect to workplace safety. Am I right? But if you come up with some other metric, that is also fine. All these things, you must be doing in the initial stages of your project, because we need a right metric so that we can judge whether our problem-solving effort is a success or not. Because this is the metric, that will tell us, yes, your effort is successful. So, in Six Sigma project, whatever I spoke comes under measure phase. After define, it is measure. You must be very conscious about data. You must be very conscious about measuring instrument. You must be very conscious about the metric you are using. Anything you say, you have to write a 2-line definition. If you say first pass yield, you have to explain what is first pass yield. You cannot simply assume everybody around you knows everything. No, you have to write down. You have to write a definition. You have to give them a formula as well. You have to write a definition. You have to give them a formula. Hey, this is the way you should calculate the first pass yield. Can one of you tell me what is the formula for first pass yield? Parts produced,
Number of
parts
parts produced
accepted,
and number accepted and rejected.
parts accepted minus,
Parts rejected.
sorry, I will say
and
like this,
deleted.
parts produced minus rejected minus reworked and accepted. Parts produced, let's say parts produced is 1000. 100 parts rejected. So 1000 will now become 900. And 200 parts reworked and got accepted. So that 200 also you subtract. 900 minus 200, 700. Divided by total parts produced, which is 1000.
Produced into 100.
So 700, 700 into 100. 700 by 1000 into 100, which is 70%.
Office.
So you have to include all these things in the beginning stage of your project. Problem description. You describe the problem, and also to come to such a conclusion, you should also be referring to the data, isn't it? Because without data, you can't say 70% or 80%. Always, when you try to solve a problem and try to ensure your problem, the process behind the problem is in a fairly stable condition. Fairly stable condition. How do I know? If you have the habit of monitoring the process over control chart and all, then it is really good. The control chart itself can show whether the process is stable or not. Otherwise, whatever amount of data available, with the amount of data, you just visualize the data over a period of time. 3 months, 6 months, 9 months, 1 year, whatever data available. And then you will see the ups and downs in your graph. Am I right? Yes or no? Any graph you plot, you will see up and down. Am I right?
Yes, sir.
And now always while defining the problem, you must try using the recent data. First guideline. You can't use the last year history and say this is the problem now. No, that you will be wrong. Use the recent one. Recent means last 3 months. Or if that is not available, last 30 days. Or last 6 months. When you use the word last 3 months or last 6 months, over that period, your graph should be stable. Are you with me?
Sir.
When I say the 3 months, over the last 3 months, your whatever metric you are talking about, that should have minimal variation. That is what is the meaning of stable. When I say yield is 70%, it is more or less 70%. If it is more or less 70%, when I calculate average, the average will be close to 70%. There should not be too many ups and downs. If there is too many ups and downs, stability is under question mark. Do you understand, all of you, this guideline? Imagine you have taken 3 months. 3 months. The recent month, the previous month, and the month before that. Let's say it is October, right? October. So we have data of September, August, July. Now 3 months data we have: July, August, September. We are in October now. Now July data, there is lot of stability issue, lot of outliers. But August and September, no, it's stable. Now tell me, how will you react now? Which period of data you would like to use it for your project? Would you like to use all 3 months? Come on, make a guess. July, August, September.
All three.
All 3, okay. Any other answer? There are three options, right? Use all 3 months or use only July. What is the other option? Use only August. Another option is use only September. There are many other options. You use only September and use August and September. Use July and August. And somebody can even think, use July and September, leave August in between. So many possibilities, all possibilities you can write down and ask yourself which is logical. And somebody said, sir, use September. Yes, I appreciate that, logical. Because there are two reasons. It reflects recent. It is recent and it is stable. It is recent and it is stable. So 30 days data, I appreciate. If somebody wanted to use both August and September, and if both August and September also stable, that's much better. Isn't it? And why, July, there were lot of, up and down, and then it settled. Something happened that period, yes or no?
Uncertainty, some uncertainty material.
Yeah. It can be a random up and down, or it can be a systemic up and down, which is someone like you in the same company would have worked on it and stabilized it. Am I right? Effort has been already taken. There are only two possibilities. One is it is random and then vanished. Sometimes that happens. Am I right or not? Problem comes and disappears. It's just random. Another thing is, if you take some, a positive, good effort consciously, then it would have been controlled that time itself. Are you following? I am not sharing any screen. I am directly talking to you. You have to be fully attentive to me and to grab everything, inside. This is a very, very important, challenge. Normally, while problem solving, people ask, and we can't give a direct, one-line answer to that. Sir, how much data I should take? No. That's why I'm, explaining this. So, if the process has got shifted, and, you consider only the recent portion because the process got shifted, no. Why do you want to consider the past? So, considering the August and September is a wise choice. And statistically, choosing August and September or choosing only September will lead to the same conclusion only. Because it is stable, if I calculate average for September or calculate average for August and September, it will be more or less same. Yes or no? That is the advantage of working with a stable process. That's the advantage of working with a stable process. So what should we do to have a stable process in our company? We must have standards.
SOP.
We must have standards.
Yes.
We must have SOP.
Yeah.
Isn't it? Wherever possible, establish standards, your process will stay stable. Otherwise, no. I know, whenever needed, train your people who operate the process. You train them properly at periodical, interval. That will result in stable result, and analysis and everything will go on very smoothly. Hope all of you understand the message here. This is the input required for problem validation. This is the input required for problem validation. See, validation means showing something with the evidence of data. I say the rejection is increased. Oh, really? Show me data. Oh, here is the data. Last 2 months, the rejection is 12%. Earlier, before that it was only 4%. I don't want the past data for the problem validation now. I need the recent. But the recent says 12%. The past is 4%. The problem is validated with the data. Am I right? There are also statistical procedure which I want to explain to you. I'll be explaining, right? But the broader definition I gave you now. Within the data, we can see a clear difference, statistical difference. Where is 4% and where is 12%? Can you see your process got shifted? Yes or no? I have only 3 people responding to me.
Sir.
And remaining people, I don't know
Yes, sir.
whether they are responding or not. But I assume, they are also listening to me. So those who are on the screen, yes, I'm expecting your head to move. Yes or no, right? Okay, so that 4% to 12% is a clear shift. Earlier, my process was fluctuating around 4. Now my process is fluctuating around 12.
12.
This is known as, this is known as process center. Your process was earlier centered around 4%. Now your process is centered around 12%. So this 12% we take into account and the problem is confirmed. If somebody asks you further explanation, then we have got some other tools. There are certain statistical testing available. Statistical testing available. That also we will learn as a tool. So what is the test? What is the statistical test I should do to validate there is a confirmed deterioration of the process if the rejection increases from 4 to 12%. If a process operates in the same manner, can rejection increase from 4 to 12?
No, sir.
No.
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 Don't increase.
4.1, 4.2, 3.9, I can say it is random. But 4% to 12%, this is significant variation. This is definitely something is influencing my process. That something is the root cause. Yes or no? That something is the root cause. That's something we want to find out in the next phase, which is analyze. So, problem description is more, the first step in most of the approaches. And also the team formation is also part of your initial activity in any problem solving methodology. When you form a team, there are certain things to understood. The team will undergo certain phases. They go through certain transformation. It is known as formation. First thing is team formation. The second thing, what will happen? There will be a quarrel within the team. Yes or no?
Yes, sir.
We form a team and then there will be immediately there will be a storm. Hey, who will be a project leader? Why I should work under you? Why you should work under me? And what are you saying? How you believe what I am saying? All these things will happen. This is second stage.
Yes.
Formation leads to storm.
Stormation
Or storm. Form, storm.
Okay.
Then what will happen if you have a methodology? If you are a project leader, you have a methodology. You have undergone, this kind of, specialized training. You know how to tackle it, isn't it? You will tell them all that whatever we are, speaking right now. You will show them data. See, this is logically I have taken data by you. See, there are 1 year data available. I have not taken everything. I have taken only 2 months. This is the reason why I have not taken remaining 10 months. There is a reason. And this 2 months data process is stable. How come continuously it can give 12%? So with all those things, if you make them understand and things will slowly settle, they'll start believing you. They might start accepting you as a project leader or a team leader or whatever. Or anybody can do that job or everybody can do it collectively as well. Nothing wrong. So form will lead to storm. The storm will now lead to a normal state. Normalize. Form, storm, and then norm. Now your team is ready to perform. Now your team is ready to perform. They are in a mood to listen to you. Sir, tell me, what should I do? Yes, let us get this problem solved. Right? So it is your job as a project leader to tune their mindset. Otherwise, namesake, all of you will be working and then wasting your resources. So that should not be the case. Educate them. Another thing you need to do at the preparatory stage, whatever methodology you follow, is knowing your stakeholders. Knowing your stakeholders, not only project team members. There are other members around your project, yes or no?
Yes, right.
And those people may have some relationship. Your solution may be important to them, or somehow they are related to the problem and the solution and the process you are trying to improve. They are related to it. But when they are related, you must call them as stakeholder. You must call them as stakeholder. And you need to now understand whether the stakeholder is supportive to you or not in a mood to support. That you must know. Because somehow you need some support from them. You may need data, or you may want them to do something in your project, depending on the kind of project you have taken. Their role is important. Some way, a little or a bigger way, they have to work with you. So you need to understand whether they are supportive or not. If they are supportive, it's a blessing. If it's a blessing, right? They are definitely going to help you, and you are for sure, you are going to get some result. But if they are not supportive, you have to take a call.
Very
You have to
challenging.
take a call. Can I do anything? Can I do anything to get the buy-in of a particular stakeholder? He is not supportive, then try to understand whether he is influential or not. If he is not influential, you can ignore. It's not going to be a big threat, isn't it? He is not influential. Just, you don't have to worry. That's not going to affect, much. There is only very little chance he can, influence. It's not much in. But if he is not supportive as well as influential, you have to take it seriously. Yes or no? Maybe let us assume he is your boss. Definitely his support. Without his support, you can't proceed. So you try to do everything that is required to get his buy. All of them are, should happen at the beginning stage of your project. This will increase success rate of your project. All of you agree?
Yes, sir.
Yes.
The way you form the team, if you create a team for, if you select members for your team, these members collectively should be able to win the trophy. Isn't it?
Yes.
And each one have a certain specific skill set. If you are selecting members for a cricket team, you need bowler, you need batsman, you need a wicket keeper, you need a fielder, you need somebody to lead others. Ensure they complement each other, not compete each other. Right? You have to assess on their skills as well. If they are very poor at the problem solving, you have to suggest them. You nominate them to our next batch. Isn't it? So here or somewhere, or you can train them directly. So some their skill set is very important. It matters. So stakeholder analysis, team formation, assessing their skill, availability of data, availability of measuring instrument, they should not be taken lightly. If you take it lightly, and you will certainly be struggling in the rest of the steps. Am I right? There are further steps available. You have to do the analysis, you have to brainstorm with your team member, and nobody will be talking to you. You want to discuss with them about the root cause, and you have a big brainstorming hall, good snacks and coffee ordered. Everything is there, but people are not really serious. They're not interested in talking to you. And they only work with the coffee and snacks you arranged, nothing else. So that situation can happen. To overcome all of those things, you work now, you plan now, and all these things really, really helps. Then all the tools you are using will produce result. It can be a fishbone diagram, or it can be a YY analysis, or it can be a brainstorming, or it can be your statistical tool, control chart, Pareto plot. Everything will start delivering results. Isn't it? Because they actually reveal the facts. These are no tools. Definitely need some data. If you want to plot a Pareto, yes, data should be available.
Yes, yes.
So each and every tool can reveal the fact, bring the fact available on your table. Not only your table, and everybody, will also come to understand, oh, this is the data, this is the fact. And so, the problem understanding is clear, and then they will also use their experience, their engineering knowledge, whatever, and then they will throw light on the root cause. And then, we can validate them. Yes, Harish, you want to ask something?
Hello, sir. Hello, sir. Can you hear me?
Yeah, very much.
Sir, so you are telling at the start of team formation, first we have to build friendships with them and then we assess the skills and discuss the problem, sir. Then only they will cooperate like that.
Yeah, definitely. Yes. Yes. You need to have, a good team. But how do you formulate the team?
Yeah.
It depends, on your ability, the circumstances, company, the availability. There are a lot of factors which can influence, but you do it consciously. You do it consciously. See, put the right people on the right job. Put the right people on the right job and find ways to motivate them. Find ways to motivate them. If you motivate, you know what will happen? The farm storm norm will happen quickly. Otherwise, by the time they come to the norm, the project duration is over. And only during the review, they realize, oh, we should have done that.
my
We should have collected data. We have
Yeah.
nothing. And tomorrow our CEO is coming for review. Now what to do? Everything, the last night they will try to do. No.
Yeah.
You push them, quickly from farm to storm and storm to norm.
Now,
And that is why we have
then
the
perform.
initial stages.
Then perform. Then
Yes.
perform.
Then only they will perform, right?
Perform.
And that
Correct,
is why
correct.
we have all these exercise. Otherwise, we
Yes,
can straight
yes.
away go to the jump to the root cause and then do all of these things.
Mm.
All right. So likewise, this is very logical approach only. All of you will be definitely following, but then there are certain theory behind which you should know, and that is what I explained you today. So what will I do? I will now take you through the yesterday's pending, and then we will see some case studies straight away, because the rest of the steps will be in line with that only. Any one method you just understand, either 8D or DMAC, and automatically the QC story, you will be a master of QC story. Automatically you will be a master of A3 as well, right? And or any other methodology also. So I'm just sharing my problem solving. Yeah, complete screen. Okay. Yeah, 80. This is what we. So the whatever material I used, I have shared already. See here, these checklist, this checklist is also based on such understanding only. After selecting a problem, they realize, there are certain things beyond your control. So these are ways of the best practice by which we reduce the risk of failure in our project. Okay. Yeah. So though we covered certain things, so I'm just quickly recalling. So team formation, then problem description, then interim containment action, root cause analysis, then selection and verification of corrective action, then implementing and validating the corrective action, then identifying and implementing preventive action, and finally celebration, closure, recognition of team and individual. Yes. These are the 8 steps in 8D methodology. We call it 8 disciplines or 8 steps, right? So remember these steps, or you can always refer to the material and then you can follow accordingly. So team formation. So, and moreover, what is the message here? Even though the steps go, or we, normally steps means we go, in the same sequence, but it's not compulsory that you should follow the sequence. Certain works you can do parallelly as well. Isn't it? Containment action, let it go. Parallelly, root cause analysis also can happen. Nothing wrong, isn't it? What is containment? Containment action is your third step. You all know what is containment action. Problems should not spread further. Do something to stop spreading of the problem. At the same time, parallelly, you can work on the root cause as well, nothing wrong, right? So that you will be able to quickly solve. So the point here is these steps, these steps can happen parallelly as well. There are overlapping. All of you can see that, right? See here, some overlapping happens. This is quite common and it's a good practice only. Nothing to be worried about. And some examples of the problems or the failures. 0 kilometer failure. 0 kilometer failure means even before releasing the product, a failure is observed. Yes or no? So before releasing the product, the failure is observed. Okay. And so many, different types use internal complaints, external complaints, non-fulfillment of, the service level agreements and all that. Okay. So this is what I told you, knowing about your team and knowing about your stakeholders and all that. And you need to do some planning so that your efforts can deliver result. And this is considered as 0D or pre-8D. Okay. See here, team selection, time frame, planning the time frame, planning for the resource required, and judging on the problem type, whether the problem is chronic or repetitive, and its previous history and whatever available, all that you can gather. Okay, and establish the team. You know now how to establish the team. And normally in 8D, we plan a cross-functional team. We plan a cross-functional team. A cross-functional. See, if you know the what to say, the problem properly, you will certainly be able to form the team accordingly, right? Like you should, if you say you have understood the problem, you must necessarily have a clarity on the pain metric. What metric I should use? That's what we were talking in the beginning of the session, right? KPI. Which KPI I need to work on? Which metric can help me to understand the problem? And once the metric is decided, the processes connected to the metric. The processes connected to the metric. And overall linked to the process. And now your team formation is very clear. People who are connected to the problem, some of them will be part of your project team, obviously, isn't it? Some of them will be part of your project team. So you, in order to formulate the cross-functional team, you need to have a clear understanding of the problem. And then you need to know the stakeholders related to your problem. And accordingly, you form a very good cross-functional team and to drive your project. And normally in 8D, 4 to 8 people. And there is a similar structure: project sponsor, team leader, and team members. And then you establish the team, and you can even write down the roles and responsibility. And see here, the second thing, problem description. In order to write a problem description, you can use the is not analysis. Ultimately, the outcome of the second step is the correct metric is picked up. It can be first pass yield, or it can be customer complaint, or it can be CPCPK, or it can be processing time, or it can be cycle time, or it can be lead time, or it can be a proper metric, percentage on-time delivery, number of incidents, and the current state and the desired state. Hope you are with me. If you have answer for all these things, the problem is described well. Now you can write back to your customer. Customer has wrote a complaint. Now you can write back to customer. Yes, sir, we acknowledge your complaint, and we have understood the nature of the problem, and we have identified the process to be investigated, and we have already formulated a team, isn't it? We have already formulated a team, and this is the metric that we are going to improve, and this is the target value, and this is the current state. And because of this gap only, the particular problem got triggered, and and this will be resolved in a span of another 30 to 90 days, whatever. Now you acknowledged your customer, isn't it? Right? And with a solid manner, whatever complaint customer has communicated, you have understood. You have taken some steps. You formulated the team, right? And for that, and that is what is called as D2. Okay. And now these things you can easily understand. So yesterday itself I spoke, and even if you read these notes, you will be able to relate what has the problem and what does not has the problem. Where is the problem and where is not the problem. So this comparison, always when there is a problem, you select the good part as well as the bad part and compare what is there in the good and what is there in the bad. What is, what kind of defects are present in the bad parts, and those defects are not present in the good parts. So this will take you to a greater level of understanding about the problem. Okay. And this is your third step, isn't it? Immediate action. Immediate action is your interim action, containment action. This is containment action. Avoid spreading of the problem. In order to avoid spreading of the problem, you can initiate, you can increase the inspection, you can, whatever, some additional resources can be allocated. All of those things, you can try to do. You can create awareness to your operators. You can create awareness to your operators. You can, educate them. Yeah. All these things and additional checkpoints because, the problem got triggered. Then step number 4. Step number 4 is root cause analysis. Here comes your brainstorming. Yesterday, we talked about brainstorming. We talked about, YY analysis. We talked about fishbone analysis or cause and effect analysis. But all these tools will work better only if you have the right people around you. Very, very important, right? Because only it is based on their input, you develop the fishbone diagram. Right? It's not that, fishbone diagram populates, automatically. No. They only gave the input based on the past knowledge and, based on the available information and the brainstorming input we create. And what is the purpose of creating fishbone diagram? Important tool. Every problem solving methodology should necessarily have a fishbone diagram, which is listed as one of the 7 basic quality control tools, 7 QC tools, right? It is listed as one out of it. The fishbone diagram is compulsory at this stage. And the head of the fish should talk about the pain metric, the KPI, which you want to improve, isn't it? The loan processing time, that is at the head of the fish. Then the bones, there is a central bone and there are side bones. Then the side bones should be categorized. Normal way of categorization is 6M or 4M or relevant method. And then all the causes, that is why I'm stressing here. All the causes, we call them potential causes. All causes. Why there is a why there is a overweight, obesity or overweight. There are several reasons, people become obese. Can you write all the reasons? Then your fishbone diagram is ready. Are you with me? While creating a fishbone diagram,
Yes, sir.
you think about all possibilities. What exactly has gone wrong? That's next step. But while drawing a fishbone diagram, how things can, would have gone wrong? What are the possibilities? You write everything. People become obese because, they don't have any physical activity, because they eat more, because they live in, such a poor environment. So everything you write, because he is taking some other medicine, because he has bad friends, so many things. All that you write. The outcome is fishbone diagram. but to bring a more, to come to a better understanding, put these factors under certain buckets. You have so many causes, put them in some category of buckets. And the usual way is men, machine, method, material, isn't it? Measurement. This is the usual way the categorization happens. But do you think it is compulsory we should always have 6M? Can we change?
Preferred to have all.
We can change.
Yes,
We
we
can
can customize. We can customize.
If we have a justification, if there is a necessity, we can change.
Depends upon the case.
Yes, yes.
Depends upon the case. Depends upon the situation.
Very good. Depends upon the case, and relevant categorization can be done. And then we proceed with separating the most, see here, potential causes. From that, once a fishbone diagram is ready, we handpick certain factors and call them as most likely causes. How to handpick? I'll tell you. Earlier we spoke about obesity, right? Now for next 5 minutes, we will speak about your obesity. Do you understand? Earlier we spoke about obesity in general. But now what are we going to talk? We are obese now. Why am I obese now? I very well know. I eat food from hotel. I have that habit. Yes or no?
Yes.
I like, the non-veg. That too in the night time, I like biryani. I will write down all these points which I know about myself. So the thinking process is different now. Earlier, in general, what are all the factors that would have caused obesity? That will reflect in fishbone diagram. But from the fishbone diagram, I now handpick. How did I handpick? If somebody has to understand, then I have to show them some methodology, isn't it? Hey, this is how I picked up these factors as most likely causes. For that, we have some tools. The name of such a tool is cause and effect matrix. What is that? Cause and effect matrix. And with the help of the cause and effect matrix, for each and every factor, I assign a rating. Since I know biryani is an important factor, isn't it? I must stop eating biryani in the night. That action is definitely required. So what will I do? Against a biryani, I will give a big rating. Correct? For every factor, I have to give a number, and we will have some rule, because any method, we will immediately create a rule. If the impact is high, found to be high, we give a score of 9. If it is moderate, we give a score of 6. If it is very weak, we give a score of 3. So eating non-vegetarian food is the factor. I very well know I eat non-vegetarian food. I particularly eat mutton biryani every day night. So for me, I put 9. When it comes to you, you are a pure vegetarian. You are a pure vegetarian. You know about you. And what is the factor we are talking? Mutton biryani. And that factor is not at all applicable for you, isn't it?
Yes.
So you can give the lowest rating. So in your case, that factor will not have any impact, any effect at all. It's the same factor, but in my analysis, I am putting 9, but you are putting only 3. Because you don't want to investigate on that, but I want to further investigate on that. Yes or no? So
Yes,
in
sir.
this manner, if I put the rating, and I can have multiple people giving the rating as well. Nothing wrong. I will put rating from my side. I will also involve my wife, because she actually prepared that biryani. So she should also be involved, isn't it? So she will also tell, yes, You are very often, asking me to cook biryani. Yes. This is one of the culprit. So you can involve multiple people in this ranking process. Isn't it? And then against every factor, a number is available. Am I right?
Yes.
And whichever factor that has a bigger rating, that should be separated from the whole list. And now they should be given a new name. What is the new name? Most likely causes.
Most likely causes.
Most likely causes.
Do you understand the procedure I suggested? This procedure is, to convince, whoever questions you. Whoever is questioning, your boss might ask, hey, how did you say this? Sir, see here. We did separate meeting, separate analysis we conducted. And we involved 3 experts, including one external expert. That external expert, is a dietitian. And in this manner only, we gave the rating and look at my numbers. And so this is, getting a higher score. So this way, you can, answer any query that is coming. You are now moving towards what? Moving towards the root cause now,
Verification.
isn't it?
Yeah, root cause. Yeah.
You are moving towards the root cause. Earlier, you started
Analysis.
with the potential causes or possible causes. Some company call it as possible causes. But from the possible or potential, we now moved on to most likely. When you look at the list of possible causes, it's a big list. There are 65 factors. But when you look at the most likely causes, there are only 18 factors. Do you understand? 65 reduced to 18. All 18, we'll do a deep investigation now. We'll do a deep investigation. We prefer to go through the data pertaining to each most likely cause. For each cause, we will go to the extent of referring past records. Last 3 months, last 6 months, or even we conduct, live experiment and generate data. We conduct live experiment, generate data. So data will be now made available. Now, with the help of the data, we'll try to validate our understanding. You all told me biryani is the culprit, right? Now I have so much data with me. People who have the habit of eating biryani, I have data. People who do not eat biryani, that data also I have. Isn't it? And the report, the data is telling me a major percentage of the people who eat biryani, they're all obese. The data is telling me now. Are you getting my point?
Yes.
But there are a few who eat biryani as well as, not obese. They are still slim. Always, such people will also be there, right? Some people are blessed. So they will certainly be there. Outliers will be there. But majority is, aligning with my doubt. Can you see that? Now, data is also giving you a piece of information. Data is confirming that biryani is one of the culprit. Do you understand? So if data also confirms, the most likely causes will now be considered as, will now be called as verified as root cause. Verified as root cause.
Root cause.
Hereafter, you can call the factor as root cause. You can change the name.
Hello, sir.
Why? Data has confirmed. Yes, Harish.
Sir, the identification of most likely causes is based on bigger rating. Then the verification of most likely causes is based on how far the data is collected, sir, like 3 months, 6 months, like that. Yes, sir?
Yeah, see, data collection, I already gave you the hint, right?
Yes, sir.
Data collection plan, we spoke in the beginning of the session.
Yes, sir.
Right? That time itself, you have to spend extra half an hour or 1 hour and write an additional information about data required for root cause validation. Data required for root cause validation. But I have a suggestion again. Since it's a very critical step and also a critical question, and I will suggest you, a data is considered to be valid. A data considered in your analysis will be valid if the risk involved in your data is below 5%. Do you understand my statement? The
Yes, sir.
data
Yes, sir.
you use, the data you used for making any conclusion is considered to be valid enough if the risk involved in the data is below 5%. And since I used the word risk involved, I should also tell you how to calculate the risk, isn't it?
Yes.
All of you, are you seriously interested? Because it's a statistical question,
Yes, sir. Yes, sir.
right? If
Very
you're
interested.
Yes, sir.
seriously, yeah.
Interested, sir.
Interested. Okay. So there is a way out to calculate the risk involved in any data, right? The risk is nothing but probability of failure. The risk is nothing but probability of failure. I toss a coin. We both play a game, and it's a head or tail game, right? And you are calling head. Now, what is the chance of succeeding?
50-50. 50-50, sir.
50%. What is your chance of failure?
50%.
You know your risk involved, isn't it, in your game?
Yes.
The risk involved is 50%, isn't it?
Yes.
And your idea of making money in the game is a poor idea. You have equal chance of success and equal chance of failure, isn't it?
Yes.
And you should not play games in that manner. If you want to play a game, your chance of failure must be minimal. If you want to use the data, the industry practice is the chance of failure or the risk of your decision misleading you. The data making you take a misleading conclusion. You trust the data and take a decision, isn't it? But data has a tendency to mislead you. It happens sometimes. No, they declare holiday, anticipating a rain. Because of prediction about the rain, they declare holiday for the school. But the next day there will be a very heavy sunlight and everybody will be playing on the road, isn't it? Now what
Yes.
happened? The data you used, gave a misleading information to you. See, this happened randomly. Nobody does this kind of mistakes, purposely. Yes or no?
Yes.
That's a randomly happened. So always when you judge something as a root cause, there is a random chance you can misjudge. That random chance must be below 5%. We can statistically calculate that. Just now in the head or tail game, you calculated very correctly yourself. Why you calculated very correctly yourself? Because it is a discrete data, just like your pass or fail, good or bad, it is head or tail. If you are dealing with discrete data, it's an easy job. You can calculate the probability. But if you are dealing with a continuous data, what is continuous data? Time, diameter, thickness, these are all continuous data, measurable. You need instruments to measure, yes or no? What is the
Yes.
probability that thickness can be between 2 centimeter and 2.2 centimeter? What is the probability it is between 2.2 and 2.4? Very tough questions. So we definitely need that. I will teach you one method, using some software. Using some software, the probability of the failure, or the better word is risk. The risk involved in our data. If I use the available data for decision making, the risk involved can be estimated. If the estimated value is below 5%, I will proceed with the decision and declare whatever my data is telling me. If my data says the factor is a root cause, I will also underline it as root cause. Are you with me? This
Yes,
is
sir.
the method, right? So now all of you are
Yes,
very
sir.
clear in moving towards the root cause. Your starting point is potential causes. Other name is possible causes.
Process.
You can also use the word possible causes. Then we move closer. Then from the possible causes, you separate
Most likely.
most likely causes.
Likely.
Then each of the most likely causes, you verify whether it
Root
is
cause.
a root cause or not. And then if the verification is successful, you will also call it as root cause. If the risk is found to be more than 5%, we drop the idea of calling the factor as a root cause. We'll release it for now. Because the benefit goes to the suspect. When the umpire is doubtful whether it is out or not, the benefit will be given to the batsman. Okay, you play. Isn't it? The same manner,
Yes, sir.
if the risk is found to be more, we do not take action against such causes. Why? Why this methodology? You are taking some action in your company, isn't it? You are taking some action. Assuming this is a root cause, you are taking an action. And your action can deliver a good result. Your action can deliver a good result. But now, since the risk is high, instead of delivering a good result, your action sometimes may deliver what? The opposite, a bad result also. Whether you are helping your company or not, please do not disturb anything that is going on right now. Good advice. Am I right?
Correct.
By way of taking action, whether you are able to help improve or not, please do not destroy anything that is currently happening. For that matter, you should not touch any factor if the risk associated is more than 5%. Correct? Correct advice?
Yes.
Yes.
So, this risk in statistics can be measured using a tool known as p-value. Keep it in mind. The risk involved in using any data, can be estimated using a tool p-value. P-value. P means probability. The full name of the tool p-value is probability of significance. What is it? Probability of significance.
Significance.
So just remember this. You don't have to know. Just a second. Yeah. You don't have to do the calculations manually, but we'll find ways. We'll find a way. How can we actually calculate it with some software or something, right? That we will try. So the root cause idea is clear.
Yes, sir.
If this
Yes, sir.
idea
Yes, sir.
is in you, if this idea is in your background, you can use any of the tool. Y-way analysis, brainstorming, and there are different types of brainstorming available. Whatever you want, you can use. So then the discipline 4 root cause analysis. And
So
so
I just
we
want to
know.
ask,
Yes,
this
yes,
is
please.
Kavita. So I
Yeah.
just want to ask if this 5% is a standardized number or will it differ based on the company or the issue?
Yeah, good question. Good question. Excellent question. And the 5%, what I told you, is a general practice, right?
Okay.
Industry, general norm. But then industries like, pharma and healthcare or, some other, critical areas, they might, want to, what do you call, work with higher level of accuracy, because when we say the risk is 5%, our the rest 95% is known as confidence level. Rest 95. So sometimes the companies would like to work with higher level of confidence. That means the risk should be further reduced. 5% is not enough, not good for me. I would like to work with only 1% risk.
Okay.
If there is a special scenario, very critical area where even the 5% risk is unacceptable, then it can be changed by the industry and it will be declared as part of your analysis, right? And this percentage, 5%, whatever we are talking, is known as level of significance. This is
Okay.
known
Is
as
it mentioned in any standard? Like, can we take it from any standard, like for example, ISO or any ISOs, or like where can we exactly see like what kind of percentage is
in
defined?
statistical analysis. In all statistical procedure, it is available. It is
5%.
available, but I don't think ISO is demanding too much of statistical analysis.
Okay.
But if you come to the side of the companies, they believe in Six Sigma.
Okay.
So Six Sigma is a data-driven approach. It demands for statistical analysis. It demands for statistical analysis. Every project, the validation is an important component.
Okay.
So, definitely, the companies that believe in Six Sigma, this is, required. This is required. Statistical validation is required. However, there is no specific prescription. It should be 5% or 10% or 1%. But 5 or 10 or 1 can be decided by the company. The domain.
Okay. For each issue also, for each issue or each type of category, like for example, device is separate, software is a different. So that risk
Correct.
can be fixed, subjective. It's a subjective, right?
See, if I fix 5%, what does it mean? I am admitting 5% risk.
Okay.
I am admitting 5% risk and proceeding with further course of action. If I admit 10% risk, tell me what will happen. My decision, the chance of my decision going wrong is very high, isn't it? See, I can travel in a bike and at whatever speed I want.
Okay.
If you travel at 40 km speed, there is a risk involved, yes or no? Because it is a highway, definitely no. People from the other side can come faster. Many issues are there. There is a risk. I am okay to admit that.
Okay.
Another person, he want to ride his scooter 60 km speed. He is willing to travel with higher level of risk, yes or no?
Yeah.
Yes. Correct?
Yes.
And one other person, he is traveling at 80 km speed. Now his risk level will be definitely higher than the other two. Am I right? Madam, are you following me?
Yeah.
Yeah. And another person, he is riding the scooter at 100 km. His risk level is, in terms of percentage is very high, isn't it?
Yes.
Now, who has the chance of reaching the destination safely? The person riding the scooter at 100 and 120 km, they will reach, for sure, or the person who is riding at a lower risk. And obviously, the one with the lower risk. So nothing wrong in reducing your alpha. But increasing your alpha, you have to do it logically, isn't it?
Yeah.
If you want to, fix, alpha, level of significance. Level of significance is also, we normally refer it using the symbol alpha, right?
Okay.
Alpha equal to 5%. If I change alpha equal to 10%, I should be doing it consciously. But changing to 1% is too good. Changing to 1% is really good. You can do that. But then, enormous amount of effort is required to declare your root cause.
Okay.
I hope I have answered your question, right?
Yeah. Thank you so much.
Yeah. So that's how it is. So see here, now we know the knack of moving from problems to symptoms and then symptoms to
Hello,
causes.
sir.
And particularly root causes. Yes.
Sir, the previous slide, what is the difference between technical review and systematic review, sir?
Wow, good question. Good question. Technical review means you will be reviewing only with respect to the process. Only with respect to the process. But there can be constraints at, as a matter of policy, your management, level constraints. Yes or no? Do you understand? See, you check everything, with respect to the process. Everything is, everything in your scope. You have tried. Still, you are not able to figure out the root cause. Do you understand? Systematic review means the root cause is beyond the scope of your process. Let's say, I think Syed, you have to mute yourself. Syed, you have to mute yourself. Yeah, I'm able to mute him. All right. So, systemic review means you have to understand from the, what you call, system perspective. Let's say your machines are old. All your machines are costly, but your machines are old. You are doing the root cause analysis, but you are not really able to what to say, change the machines. You cannot take action, isn't it? Because the machines are costlier. Only your management can make such a decision. So in those points will be taken up and put up to the management. After doing the technical review, we will be doing a similar exercise with the systemic review. Do you get my point? Let's say your employees are having a very lower level of motivation, right? Maybe for some other because of the policy that exists, there is a possibility. So this can again be taken up only at the system level. Process level, you can't do anything. Are you getting my point?
Yes, sir.
Okay. So same fishbone diagram, you may have to create considering the system level factors. And then you will be able to put up that fishbone diagram to your top management. And then if they could come forward to support you, then problem can be resolved as part of your project. Hope it is clear.
Hello, sir. So
Yes.
so in technical review, first we you said machine is old, then we'll do systematic review. In that review, what we'll do, sir? Systematic review.
You consider elements, beyond the scope of your process. Say, for example, we are conducting the training program in the evening time, isn't it?
Yes, sir.
In the evening time. And few participants are not really able to follow. Few participants are not really able to follow because they are traveling, because they are in the office, because they feel sleepy. It's time is already closer to 10. Am I right?
Yes, sir.
Yes, sir.
Are you able to correct it? Are you able to take action on all of these things?
No, sir.
No, sir. No.
So there is a systemic issue. Yes or no?
Yes, sir.
Process level, I can only try to explain better, show more examples, play
Yes.
videos and give you notes, and these are process level.
Yes.
But ensuring every participant is not moving, ensuring every participant is awake, active, and ensuring everybody is not sleepy, and all of those things are beyond the scope of my process. Probably the solution could be conducting the session in the morning. But system level decision must be taken, not at the process level. Am I correct?
Yes, sir.
Maybe for one batch, we can say every alternate batch, one batch will be in the morning. This is a solution by making changes at the system level. So sometimes it happens to you as well, yes or no? But you will not know how to project it. And here is the guidance. Are you getting my point?
Yes, sir.
All that you can do at your level, do it with the technical review, which you cannot do, but you really wanted to project. Then you come on to the other side and create another fishbone diagram and show it. Okay?
Yeah, and on the top of that, Dr. GSK sir, it is very subjective, and we need to connect with our daily day-to-day operation. Then only it will be very easy to understand this. Very subjective.
Correct.
So as you said in that another fishbone diagram, we have to mention what is the wrong in that system, right, sir? Wrong in that system
Yeah.
and what can we change it like that?
The same procedure. It's not that, we again, work as a team and move from the possible to most likely to the actionable causes. Same method.
Okay, sir.
Okay.
Excuse me, sir. One more thing. We need to consider the value of the atoms for these problems?
Value of
the atom for which value of the atoms which are under problem.
You mean to say about the finance part?
Yeah, value. Suppose what happens sometimes if anything rejected, the price is very much high, and some atoms price is very less.
Correct.
We need to consider?
See, that should be taken up in the initial stage of your project itself. Like, every project will have, certain financial impact. And I told you, if there are multiple problems, you need to select based on the criteria, certain criteria. If if cost is an important criteria for you, and if there are 10 projects, and you can choose the one that has highest, financial benefit. But anyway, we will be solving, everything one by one. But the first to go will be one with the highest financial impact.
Okay.
Right. But right now, the idea is, root cause analysis.
Yes.
Here, cost has a lesser role to play. Process level, we are just, technically, we are evaluating.
Okay.
Good.
Okay,
So we know all this brainstorming, and then the YY analysis. These are simple tools. In fact, we discussed yesterday. We again revisited purposely to develop a deeper understanding, right? And I'm very sure all of you are master of these kind of simple tools, 7 QC tools, like your brainstorming, YY analysis, the fishbone diagram or Ishikawa diagram and all that.
Sir?
And it is also called as a cause and effect diagram.
Hello.
And the same, the obesity case is
Sir?
visualized in the form of a fishbone diagram.
Sir?
And this is for an e-commerce delivery related. Like, there is a wrong delivery, there is delayed delivery and things like that is happening, and the fishbone diagram is drawn. And I was telling you cause and effect matrix. You can see one such matrix here. There are how many potential causes here? 1, 2, 3, 4, 5. Can you see here? 1, 2, 3, 4, and 5. And then the criteria considered are, see here, the product defect and its impact on the cycle time, its impact on the customer satisfaction, its impact on the cost per unit, and like your point is also here considered. And based on that, the rating was given, sorry, 1 minute, material quality. Yeah, causes are here. Sorry, causes are here, and these are
Right.
Yeah. Correct. Yeah, these are the criteria. These are the causes. Now, whether material quality can be a root cause or not. And the material quality is related to product defects and cycle time, customer satisfaction, cost per unit. Some ratings are given. And the total priority score. Okay. I think, yeah, 1 to 10. Yeah. Actually, we really have to have some kind of weightage number here. Some kind of weightage number we have to give that is not indicated. But however, once the weightage value is given, let's say high weight means you can say 3. Medium weight means 2. And low weight means 1. Something like that. No, you have to assign some number. And afterwards, you have to actually multiply the weightage with each number. You understand? You multiply the weightage with each number. If you have an equal weightage, you don't have to mention anything. Simply sum them up. All the ratings, sum them up, and you indicate the total here. But if you have different weightage for the criteria, then that weightage rating must be multiplied with this score. Are you getting my point? So after multiplying with the weightage score, you have to total them and indicate the total score here. In this manner, for every most likely cause, you have to give a rating, for every possible cause, you have to give a rating, and whichever qualifies according to your criteria, that should be separated as most likely causes. This is the way you can separate most likely causes from the list of possible causes. This is only an illustration purpose. I just made it for your understanding. I have shown only 5. Out of the 5, 2 is classified as most likely.
Hello,
and there
sir.
is no hard and fast rule. There is no hard and fast rule here. You can have your own rule.
Sir,
Yes, Arish.
95 is also a higher number, sir. So we also take that
That's
also.
what. No, correct. That's what I'm telling you. It all depends on the weightage you assign and the scale you work with. You can have a 5-point scale also. You can have a 10-point scale also. You can have any kind of weightage. 1, 2, 3, I said, it can be 3, 6, 9 also. So the numerical value really do not have any meaning. What is important is what comes first and how many factors you are willing to verify. Because, verify means, deep investigation. Right? Let's say out of 25, I want to start work with top 5. Now, whichever 5 comes in the top, I'll take it and try to solve my problem with the 5 itself. If I am not getting my problem solved, then I may have to choose another 3. It's okay. Do you understand? So this is only a logical approach we follow, so that we work with the factor that have a higher chance of becoming a root cause. See how a police will investigate. If a crime happens, they come to the spot and take 5 people from that spot, and they proceed with the investigation. Later they realize all the 5 are not the culprit. Will they hang all of them? They'll release.
No, sir.
Then what they do next? Take another 5, isn't it? Okay. So that's how it is. Let me quickly finish it. And another alternate is a high impact control matrix. Another tool is impact control matrix. This will also serve the same purpose. You have to logically classify your factors into high impact, high control quadrant. If a factor has a higher impact, like I was saying, eating biryani in the night, and can be a reason for the obesity. Now tell me, can this be a high impact factor for yourself? Yes, for me it's a high impact factor. You know why? Because weekly, twice or thrice, I have the habit of taking biryani. For me, it is a high impact factor. Do you agree, all of you?
Sir.
Yes.
Sir. Yes.
Yeah. What happened? Is it any time factor started playing? No. We'll be finishing in another 5 minutes. Okay. So it is high impact. And will I be able to change my, diet? Change my habit of, taking biryani? Yes, I believe in my, ability to control myself. So it's highly controllable. Do you understand? So I will be writing biryani here. The moment I am able to write biryani here, then it should be called as a most likely causes. This method is an alternative to this method. Whichever you are comfortable, you follow that. But in both case, you have to be realistic. If I ask you, what kind of food, you are eating, and so that, I could understand the reason for your obesity, you must try to reveal the fact. Then only we can figure it out as a team. Hope you understand what I'm telling, isn't it?
Yes, sir. Yeah.
So the input should be realistic. That is why I told you, prepare your team, prepare your stakeholders, and get their buy-in first. Then only they will reveal the fact. Okay. So now comes
So
what?
before ending, sir, only one query, sir, Dr. GSK, sir, regarding the
Yeah.
p-value you have mentioned, the probability of significance. Anything like threshold cutoff is there, or what is the acceptable criteria, sir, when it comes to
I
p-value?
think you can relax up to 10%, not more than that.
10%. Okay, sir. I got it.
And relax up to 10%, right? No, the risk, maximum risk we can admit is 10%. At least 90% confidence is required. And if it is very critical, you want to be very accurate, then you must, you should also be reducing it to 1%.
Hello, sir.
Yeah.
Sir, in the impact control matrix, for low control and high impact, what should we do, sir?
Low control and high impact. Let's say your obesity is because of some genetic reason.
Okay,
Do
sir.
you understand?
Okay, sir.
What will you do? What action will you take to change your genetical reason?
Nothing.
High impact. If the gene itself, is making you obese, you can't do anything, isn't it?
Yes,
It's
sir.
definitely high impact factor. But will you even go to the extent of controlling your genetical influence?
No, sir. Not
No,
possible.
right? So time being, you leave it. It's uncontrollable. Low control means uncontrollable. You focus on the controllable. Then who will focus on uncontrollable? God will focus on uncontrollables for you. Your job is to control the controllables. To do your job properly. God will definitely do the best for you. Correct?
Yes, sir.
Yes,
So
But
our,
if you don't do your job properly, then God will also start going against you. Then you will be under heavy risk.
so our must priority is high control and high impact only, correct, sir?
Correct. That is why I told you, you focus there.
Yes, sir.
Okay. Okay, Harish?
Okay, sir. Okay, sir.
Done. So verified measures with action plan. Whichever factor got verified as root cause. Now we need an action plan. How to stop biryani? I'll strictly tell my wife to not to cook biryani more than 1 day in a week. Isn't it? This is a kind of action plan. So same manner, I will also find out alternative dishes. There are many other ways. So you have to brainstorm with your team, right? And then create a action plan and see the first few steps. If you do consciously, all the other steps, you will start enjoying. It won't be, much difficult. And if you are not getting, enough progress here, it is because of the mistake or the gap you created in the initial stages. All right. So certainly you will be able to find out the, the corrective actions, and you do, involve your team, involve your stakeholders, and see here, be practical, consider the solutions which are feasible, and consider your organization criteria, cost effective, and let your solution be robust, and all that you can consider. So examples of corrective action: introducing additional control in other process, select a control point improvement for the rework the defective units, and these are all some just an examples, but the relevant one you can choose. And then the validation. What is that? Yeah, the last thing, yeah, I mean, the corrective action, we are now trying to ensure the lasting of the corrective action, which is currently in use. Nothing but the preventive measures. what kind of preventive measures we can do so that our corrective action or the results of the corrective action can be sustained over a longer period of time. And this also can be logically arrived, and you validate your solution. That is, whatever corrective action you have taken, whether it has really fetched the result or not. Wait for another, particular period of time, gather the data, and ensure your new statistics or the metric, whatever you started with the project. Understand the improvement getting observed in the same metric, and that is validation. And don't worry, the validation part I will conduct as one day I will conduct a separate session. The statistical procedure alone I will be teaching all of you. Probably tomorrow also we can have that. All right. And once that is done, then we can go through the case studies and the lighter tools. And I am very confident you will not have any issues. But during the session itself, but through question and answer, we can develop a good understanding, like how to do the brainstorming and all that. So you validate. Validate means we again collect data and ensure the results reflect in our data as well. Original rejection is 12%. Now the rejection is below 5%. That means we have got the result. That means there is, our solution is validated. And of course, the preventive action also, like monitoring some of the metrics or some of the characteristics, some of the factors through a control chart, and upgrading our control plan, and all those things we can do it to ensure prevention of reoccurrence of the problem. And finally, the 8th step is celebration. Now the sponsor has to certainly come and participate in the celebration, congratulate the entire team, isn't it, for the effort and the result they have achieved. And suitable reward system can also be created so that continual improvement culture can spread across your organization, right? So this is what is the 8D. The benefits are visualized. So what is this? Edward Deming saying, quality comes not from inspection, but from improvement of the production process. That is what we also know improved as part of our project. We improved the process. And all right, so I should stop here.
Hello, sir.
Yes.
In discipline 6, PCA means prompt corrective action, sir.
PCA means potential corrective action.
Potential corrective action. Okay, sir.
Yeah. So that's it. So thank you very much, all of you. I think we spent some extra time as well, but I think still going through all the steps in detail has helped in strengthening your understanding to a greater level. Is my understanding correct?
Yes, sir. Thank you.
Okay. Shall we meet tomorrow then?
Yes, sir. Yes,
Sure,
sir.
sir.
Thank you.
Thank
Thank you,
you
sir.
very much. Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah.